There we go.
All right, well, good morning, everybody.
Good morning.
So today we're going to be talking about square roots and cube roots. Why are we talking about square roots and cube roots in a section on exponentials? We're in a sector area on exponentials.
The opposite of exponentials.
True.
Roots.
The other reason is if I write 2 squared here is the same as 2, or excuse me, the square root, the square root of 2 is the same as 2 to the 1/2. So, in a sense, square roots and cube roots are just a continuation of exponentials as well. So those are equivalent. Okay, so the big idea in 8.6 that we want to understand is that if we have some amount, we'll call that A.
Does everybody have paper out for notes?
Oh, yes. Paper for notes, yeah.
I know. Right as you said that.
Okay, so if A, which is some amount, if that equals S squared, does anyone have an idea? So what S would equal what then? Okay, no, it wouldn't equal A.
Would it be the square root, right?
It is, exactly, yeah. So that's the big idea to begin with. So let's give some numbers here. So let's say we have some. So if we say that like 16 equals S squared, so that's our amount. This is what we're trying to find. That would work out to be the same thing as S, given our formula here, equals the square root of 16.
Or, how else could you write that?
Yes, so what's this equal? Anyone know what the square root of 16 is?
4.
4? Is it just 4?
4.5.
Okay, so it's plus minus 4.
What?
Does that
Okay.
make
I've never seen that notation.
Okay, so that means it's either a positive 4 or a negative 4, because both of them solve this, right? Because remember we talked about yesterday the even exponents, right? So here if we try to get 16, if we multiply a positive 4 and a positive 4 times each other, we'll get 16. And then if we multiply a negative 4 and a negative 4 against each other, we'll still get 16. So that's pretty straightforward. There's another concept that we want to make sure we understand. So if I have, let's say I have the square root of x, and then I'm multiplying the square root of x by another square root of x. What do you think that equals? Grayson?
Just X.
Yep. Exactly. So another way to think about that is if we had x to the 1/2 times x 1/2, that's gonna equal x to the 1, right? Because these are equivalent. So if we were normally doing this with the similar kind of idea, right? We add exponents when we multiply, right? So if this was x to the 2 times x to the 2, that would be x to the 2 plus 2 equals x 4. So we're doing it, the structure is similar here, right? So we're just adding those two. Okay. Okay, this similarly applies for cube roots, right? So if we have well, I guess just to clarify, so a cube root is annotated with a little 3 here, like so. So that's a symbol for a cube root instead of for a square root. And again, so if that's of x, that's the equivalent of x to the 1/3. So those are the same. If we have a cube root of x, though, similarly, times a cube root of x times a cube root of x, then we just get x. And again, that's the same as a x to the 1/3 times x to the 1/3 times x to the 1/3 equals x to the 1, or x. So again, we're just adding each of these up like we normally would with exponents. And when we add those up, we get x to the 1. Okay, so that is 8.6. It's a pretty short section, short, sweet, and to the point. Okay, so now we'll move on to 8.8. 8.8 is on distance in a coordinate plane. So if we're talking about exponents, what would distance have to do with exponents? Anyone have a guess? Anyone think of any formulas that might be related to distance or geometry? Yes.
The Pythagorean theorem.
The Pythagorean theorem. That's exactly right, Grayson. So, okay, let's see here. So write the Pythagorean theorem.
Are we still doing 8.6?
This is 8.8. We're on section 8.8 now.
8.6 was just short.
It was short. There wasn't much to it.
The cube root, it's the 1/3 power.
So, okay. Right, so the Pythagorean theorem, right, is just a squared plus b squared equals c squared. This being your hypotenuse, right? I don't know how to spell that. I'm not even gonna try.
Hypot in use. E-N.
Okay.
Hypot in use.
Okay.
It's a hard one to spell, but there's a way to kind of remember it. It's hypot. Don't say it. I know what you're gonna say, so don't say it.
She knows what you're thinking.
Weed eater.
Bad math. Wait,
No, it's from VeggieTales.
Oh, you're right.
Okay, here's how I'm gonna do this. I'm trying to figure out how to make this work on the board so I don't have to get too detailed. So I'm just gonna label, so this is y, right? And this is x. I'm just gonna show a shape on here and then I'm gonna label the let's see, are they called vertices?
The vertices.
Vertices of a shape, okay. Okay, so we've got A, And we've got B. And we've got C. So B is 6, 6. So the x value is here, y value is there, right? So 6, 6. C is 6, 2. And then A is 2, 2. So if we want to find AB, we have to use the Pythagorean theorem. So what's the length of AC? So I'll just put that here. So we've got BC. So the line segment here for BC squared plus it's going to be AC squared equals AB squared, right? That's the Pythagorean theorem. Okay, so what's the length of BC here?
4.
Yep, exactly. So we've got 4 squared plus, what's the length of this one here? Should be it's the same thing actually. It's also 4, right? So we've got 6 minus 2 is 4, so that's 4 squared equals AB squared. Okay, so 4 squared equals what?
16.
Yep, so that's 16. Plus 16 equals AB squared. Okay, so that 16 plus 16, so that's 32. So based on what we just did, what is AB getting equal?
Don't give it as an exact number, just say how you would say it,
Wouldn't it be, isn't that exact number?
as an exact number.
Give it as an exact number.
Oh, yes, that would be the square root of 32.
Exactly. Yep. So this here equals the square root of 32. This little segment here, the hypotenuse of the. So what you can see here is that if we create, or if we have a coordinate system like this, to find the distance between 2 points, we just can create a right triangle, and then that allows us to find the distance.
I have a question,
Yes.
Go ahead,
Go ahead. You sure?
I think you're probably gonna get rid of it.
So the next thing here, when you're doing your homework, I would be careful if we're looking for an exact answer, you're gonna want to make sure you give the square root rather than the number, because it could go on to infinity basically. The number.
Which ones on a calculator would not go on to infinity of a square root? What kind of square roots can you get exact numbers for?
Odd numbers,
No, not necessarily.
prime numbers,
Whole numbers, okay, what whole numbers?
Non-negative numbers.
Well, actually, you can square those too, you get negative numbers, but we don't usually do negative numbers. So what numbers can you find a square root of? Let's just start looking at them. Let's start with number 1. Can we find, Russ, up on the board, number 1, can we find the square root of number 1? Just make this list. Make a list. On the board, square root of negative, square root of 1. Not negative 1, 1.
Oh, I was gonna say, why are we doing imaginary numbers? Funny numbers.
Okay, yeah, I didn't mean that, okay.
What did you say?
Square root of 1, square root of 2, up through 10. So on your paper, write down the square roots of numbers 1 to 10. one more,
What am I missing here?
one more.
Square root of
Mhm.
1, right?
Yeah. Okay. What did you just circle?
I just circled square roots that have a exact answer. So right, so the square root of 1 is 1. 1 times 1 equals 1. The square root of 4 is 2, which is a whole number. And then the square root of 9 is 3, right?
Okay, so now I want you to go look at square root of 2, square root of 3, square root of 5, some of those on your calculator right now. Type those in, see what you get. You can do it two ways. If you don't see a square root button, use the fraction of 1/2 as an exponent. Everybody should be using a calculator. Phone,
That's what I'm
something.
using this on.
After you do 2 or 3, what do you notice about each of those ones that are not circled?
They give a decimal answer.
And how far does the decimal go out?
Too long.
Too long. Statement.
That's a good answer.
That is a great answer.
Yeah.
All the way.
So has everybody figured out how to do a square root on your calculator? That's the important thing. So those numbers do not have exact answers, okay? That's why when it says exact answer, if you don't have the square root of 1 or the square root of 4 or the square root of 9 or the square root of 16 or the square root of 25, you can't give an exact answer except for the square root of that number. Okay, that's your exact number when it's square root. If you approximate the answer, you put it in the calculator and you round. Anytime I round, that's an approximation. If you hear the word round, you are given an approximation, okay? Do you think the number ended where the calculator cut off when you put it in there? No. These numbers are like pi. They go on forever. Those numbers are just like pi, they go on forever. There's not an exact number.
Okay, now we're gonna try something similar to this, but a little bit different, just to see if we understand what's going on. So, I'm gonna give you 2 points, and I want to see if you can go ahead and find the distance between the 2 points.
And if you need to draw a picture, go ahead.
Yeah, I will.
Oh, no, I'm saying.
Oh, you're talking about them? Oh, okay. Let's see here. So let's see if we can find the distance between these 2 points. So the first one is 5, 8, and the second one is 7, -2. So
I'll move that. Get used to alternating sides so people can both see it. 'Cause they're
yep. Okay. So does anyone have an idea of how you would solve this?
Would you just do 8 minus 2, the bottom number, the top minus is from the bottom number.
Okay, so that you're on track to something here. So you're trying to find what the height is, right? Is that what you're saying?
Yeah,
So
just
for the
8 minus
Pythagorean
2.
theorem. So it would be the distance between these 2 points would be what? 10. Yeah, right? Because we're going from a negative.
Sorry, yeah. I was
to
just
a
thinking whole
positive.
numbers.
Yeah.
You're right.
Yeah, so the distance here is 10. So what we're doing here is the same as when I showed them on the coordinate plane, right? So we're really finding, basically, we're finding a y, and then our change in x here would be on the x part, right? And then So what we're actually solving for, or maybe it would be, there we go. You can think about this as just kind of like, we're doing this, we find out that the distance here is 10, and we found out that the distance here is 2. So then what we're really looking for, right, is the distance between these 2 points. So it's just a direct application of the Pythagorean theorem. So if that's the case, what would my Pythagorean theorem be in this case?
2 squared plus 10 squared.
Yeah, exactly, Matthew. So we've got 2 squared plus 10 squared equals,
Question mark squared, or D squared.
yeah, that's what I was gonna say, distance squared. Yeah. Okay, so 2 squared, that's 4, right? And then 10 squared.
3.16. Huh? Oh, 10 squared, not square root.
Yeah, that is a distance.
100.
Yes, it's 100. Okay, so that's gonna equal still d squared. So we have 104 equals d squared. So what does d equal?
Distance.
Yes. Yes, you're right, Max. Just not quite what I was.
And what in the number sense is D equal?
Oh, you would find the
I would be 104 squared. Or not squared, square root.
Yes. So
So
d in
10
this case.
one.
So yeah. So d, we'll call it d here. It's a bad square root symbol. There we go.
Is that an exact number?
no.
I don't think so. Yeah.
Is it written as an exact number currently?
Oh, this is currently yeah.
Okay, so then put it in your calculator, I want you to practice.
I did.
Okay. What'd you get?
198.
0.3909.
Okay, where should we round up?
It's like the second or third decimal.
Okay,
Like 10.19. Wait,
Okay.
that would be.
did you round it
10.2.
correctly?
No, 10.2, right?
I don't know, I don't see the answer, I'm asking you guys.
10.198.
I think the 10th.
And then for just to follow up, so this is the same as what? What's another way to write this?
Well, 10
To the power of 1/2.
Yes, very good. I'm glad you remembered that. Okay, so 104 to 1/2.
Or
I want everybody to try putting that in their calculator and see if they can get the same number.
I
You'll
could-
want to make sure you use parentheses around the 1/2. That'll be key.
Yeah, same number.
I just want you to show you that works every time. 1/2, we have a square root symbol. Cube root, we don't always have the cube root symbol on our calculator, so then that's why you can put it to 1/3.
What did I do?
Okay,
Wait, never mind, I know what I did. It should be like that. No? Oh.
Okay, there's
And then the
one.
parentheses
Oh,
here.
let me know when you've gotten your answers.
Yeah, I got it.
Got it? Everyone got it?
Yeah.
Okay. One more thing to remember, since this is distance, you'll want to make sure you keep in mind your units. So if this was in feet, right, we'll want to make sure we report it in feet. If it's in meters, we want to make sure it's reported in meters, things of that nature. Otherwise, I think we're ready to dive in onto some live problems. So, yes, do you have a question? No?
No.
Oh, okay.
okay, so you can stop the video. I don't wanna have to go